So there's just 4 problems left in 6.6, and I didn't want to put these at the end of the last video because there's a trick. The algebra to these problems is going to produce 2 answers. One of the answers will check, the other answer won't check. This is specifically because logarithms, if you plug a 0 in for a logarithm, you get some domain error. And similarly, if I plug a negative in for a logarithm, depending on the mode I set my calculator up for, either I get an imaginary number, which is not so good, or if I have my calculator not ready to give me I answers, if I went down and hit my mode button and I selected I only want real answers and I don't want Y answers, if I have my calculator set up like that and I try to do the logarithm of a negative number, it's going to give me that same issue. Logarithms for zeros they're not defined. For negative numbers they give me i's, and in this section, or for these last 4 problems, any number that when I plug it back in for x makes one of the arguments negative is going to be outside the domain of that logarithm and it's not going to check. Let me specifically just try to show you what I mean. I'm going to do problem 48, following the steps that I typed up. First step, I'm going to use the plus to times rule to write the left side with 1 logarithm. So on the left side in problem 48, I have 2 logarithms separated by a plus sign, and those logarithms have the same base. Kind of that sheet of big font rules that I had written or typed tells me that if I have 2 logarithms added and the logarithms are the same base, you can condense the 2 logarithms into 1 logarithm by multiplying their arguments. So I just simply use the rule that we learned in section 6.5, I believe. Now I'm going to simplify the argument by doing the multiplication. Specifically, I'm going to multiply x times x. And when you multiply x times x, you get x squared. And then I'm going to multiply 2 times x and get 2x. So now I'm done with the first 2 steps. The first step is to make one logarithm out of the 2 logarithms. The second step is to do the multiplication that is part of the argument here. Now I'm going to rewrite the problem in exponential form. All this junk here is just telling me to do this. Scratch out the logarithm, leave the base of the logarithm as the base of the newly created exponential function, and switch. The 3 becomes the exponent of the newly created exponential function, and the x squared plus 2x gets written to the opposite side of the equal sign. So that's what all of this is just asking me to do. Just get rid of the logarithm, write an exponential equation. Now I need to solve for x. So step 1 was making the 2 logs into 1. Step 2 is just multiplying the argument. Step 3, get rid of the log, write it as an exponential function. Step 4, solve for x. And it says you will need to set equal to 0 and solve by factoring. This x squared dooms me to solve by factoring. So let me set it equal to 0. But before I set it equal to 0, I'll figure out that the 2 cubed is 8. And now I'm going to go minus 8 and get 0 equals x squared plus 2x minus 8. I need to factor this, and the numbers for my factoring need to multiply to negative 8 and add, but really subtract to positive 2. They're going to be 4 and negative 2, because if you multiply 4 and negative 2, they multiply to negative 8. And if you add 4 and negative 2, because they have opposite signs, you subtract and take the sign of the larger, and they add to 2. So the numbers I'm going to need for my parentheses are the positive 4 and the negative 2. My parentheses will lead off with a couple of x's because the first term is the x squared, and I split it evenly between the parentheses. So in one parentheses, I get the plus 4, the other I get the minus 2. When you set the individual factors equal to 0, you'll get the answers that need to be checked. You get negative 4 and positive 2. And when I go to write my final answer, I shouldn't write the answer that doesn't check. So now I'm going to go into checking mode, and depending on which one of my calculators I pick, the checking is going to look different. So I'm going to check the 2 first and do is the log base 2 of 2 plus 2 plus the log base 2 of 2 equal to 3. That's just changing both of the x's in the problem to 2. This calculator with the log base feature is so much easier. So I'll do it on this calculator first. So math, log base 2, and I'm just going to write 4 here because that's what 2 plus 2 is. And then plus math, go up to get the log base. It's quicker than going down. Log base 2 of 2. And I get 3 equal to 3. So 2 is the solution. When I go to check the x equal to -4, it's going to blow up my calculator. Depending on how I have my calculator set up, it's going to blow it up differently. This calculator I just put in a mode that wasn't going to handle i's. If I click on the mode button for this calculator and you look down to this line that says real a plus bi, the real is highlighted, it won't give I solutions. So on this calculator right now, when I try to check this solution and I do the log of -4 plus 2, whoops, I'm sorry, when I do math log base, I need the base there, math log base, the log base 2 of -4 plus 2 plus the math log base 2 of -4, it's not going to equal to 3. It's going to give me an error because I don't have my answer set up to give me an i's. This is good enough to tell me this right here does not check. This is not a solution because the only time an answer is a solution is if when you plug it in, the left and the right sides match perfectly. On this calculator, if I click my mode button and you go down, you see I have it set up to give i's as opposed to not give i's. And when I check on this calculator, if I leave it in this mode, I'll show you it's going to give me an I for this bottom one. The top one will check. To do the top one, I would do log of 2 plus 2 divided by log of 2 for that first log, and then plus log of 2 divided by log of 2 for the second log, and that gives me the 3 equal to 3. That one's just fine. For the next one, for this logarithm, I do logarithm of -4 plus 2 divided by log of 2 plus the logarithm of -4 divided by the log of 2, and it gives me 3 plus 9.06i equals to 3, and that's not a true statement. So if you have your calculator in the mode a plus bi, it still shows you that that's not a solution because 3 plus 9i doesn't equal 3. The 3 part matches, but the I part is no good. So when I go to write my answer for problem 48, I should only include the solution that works. And that's the evil trick. And all the other problems before problem 48, if I don't make an algebra mistake, my answer is going to check. In this last 4 problems, I could do perfect algebra, and I'll likely get one answer that checks and the other answer that doesn't. So one more problem for each of us. Let's do 51 together maybe. So, and maybe pause the video and try to give it a try. I think 51, the factoring is going to be harder, but I'm not sure. No, there's going to be a common factor. So 51, first step, rewrite this with a single logarithm. So the plus between the 2 logarithms allows me to write the 2 logarithms as a single logarithm. The plus between the 2 logarithms and the fact that the logarithms are the same base allows me to write the 2 logarithms as one logarithm by multiplying their arguments. So I'm done with step 1. And now I'm going to simplify this argument by multiplying x times 3x. When you multiply x times 3x, you get 3x squared. And then 6 times 3x, when I multiply 6 times 3x, I get 18x. Done with step 2, I simplify the argument. Now I'm going to rewrite the problem in exponential form, and that's just scratching out the log, switching, creating an exponential function. So I'm getting rid of the logarithm. I scratch out the log. The base of the logarithm becomes the base of the new exponential function. The 4 is going to be the exponent, and the 3x squared plus 18x is going to be free of the logarithm and be off to the right of the equal sign. So that's the end of step 3. Step 4, I need to solve for x. I'll need to set equal to 0 and solve by factoring. I know that 3 to the 4th is 81. If you didn't have that memorized, you could use your calculator. So following my step 4, I need to set it equal to 0 and solve by factoring. So this is going to give me 0 equals to 3x squared plus 18x minus 81. All the numbers are divisible by 3. I should factor out a common factor of a 3. And that common factor that doesn't have a number doesn't give a solution. So when I factor out a 3, the 3x squared becomes just a plain ordinary x squared. The 18x becomes a 6x because I divide 18 divided by 3 and get a 6. The 81, or the minus 81, becomes minus 27 because 81 divided by 3 is 27. Now I'm going to try to factor the x squared plus 6x minus 27. And the numbers are going to be positive 9 and negative 3. Because if you multiply positive 9 and negative 3, they equal negative 27. And if you add positive 9 and negative 3, you get positive 6, which is exactly the two numbers I'm trying to key on. I need numbers that multiply to the negative 27, add to the negative 6. This adding is really subtracting because they have opposite signs. So now I'm going to set each of the factors equal to 0. The first factor by itself doesn't give a solution. It's going to be a coincidence that the last factor gives a solution of 3, but factors without an x don't give a solution. The factor of x plus 9 gives a solution of negative 9, which shouldn't check. And the factor of x minus 3, when you set it equal to 0, that actually gives me a 3. And it's just coincidental that it's the same as the common factor. If I was rolling the dice and I was rushed for time, I'd probably just write down my answer as x equal to 3. But I'll go ahead and check, and I'll check on my easy calculator. This calculator is so good. I'll put it in mode 1 so it gives me an error, not an I. So if I wanted to check x equal to 9, negative 9 should I say, if I wanted to check x equal to negative 9, I do the log base 3 of negative 9 plus 6 plus the log base 3 of 3 times negative 9, and that's supposed to equal 4. And hopefully you're comfortable enough with your calculator now that when I do this on this calculator, because this calculator rocks and it's so easy to use, that you can press the buttons on your calculator just fine. When I do this right now, so you can see what I've entered, I use the log base feature. I did the log base 3 of negative 9 plus 6 plus the log base 3 of 3 times negative 9. And it's going to give me some sort of error mode. So this is going to be an error. This is what you would get if your calculator is not set up for eyes. On this calculator, if I hit mode, if I hit mode in 2 and do this computation again, I'll get what you'd get if you have an eye. If I did the log base 3 of negative 9 plus 6 plus the log base 3 of 3 times negative 9, you might get this. Oh, it still gives me an error. It doesn't. This calculator is not expensive enough to do logarithms with negative. On this calculator, if I try to do this, if I did the log of negative 9 plus 6 divided by the log of 3 for this first logarithm, plus the logarithm of 3 times negative 9 divided by the log of 3 for the second logarithm, this calculator will give me an I. This would say 4 plus 5.7i equals to 4, and it doesn't because the 5.7i part. regardless of what mode your calculator's in. This calculator is in mode A plus BI, so it's ready to do I's. That's generally the mode I have my calculator in. This calculator, I changed it out of that mode, and it's in mode real, where it will just give me an error. Either way, the negative answer is not going to check. Either you're going to get an error message if you're in real mode, or you're going to get an I in your answer that makes the equation not true. Both of them are bad. I usually leave my calculator in A plus BI mode, and that's generally the better mode to leave it in, so I'll put it back in that mode. So negative 9 is not an answer, but 3 is an answer. If I wanted to check 3 on any of the calculators that I own, to check x equal to 3, you just need to know the keystrokes for your calculator. This would be the log of base 3 of 3 plus 6, plus the log base 3 of 3x, or 3 times 3. And on this calculator, log base 3 of 3 plus 6, plus the log base 3 of 3 times 3. And that comes out perfectly, where you're going to get 4 equal to 4. When I plug in the numbers for the logarithm, that's the left-hand side, makes the left-hand side equal the right-hand side. So the only answer is 3. Guaranteed that this problem is going to make it onto the test, and 99% of this kind of problem, if I make it up, the algebra is going to produce 2 answers, because you get that x squared and you have to solve by factoring. And 99% of the time, one of the answers checks and the other doesn't. And when you write your answer down, you only need to include the answer that does check. It wouldn't have been wrong if I wrote my answer like this. If I said x equals to 3 comma x equal to negative 9 doesn't check, and the proper way to say an answer doesn't check, I can't even spell it, would be to say the answer is extraneous. The root there, I guess, is extra. And I guess neos means it's extra but not good. Extraneous, if you wrote that with the negative 9. If you didn't include your negative 9 in the answer, that's fine. If you do include both the answers that the algebra produced, you need to make some sort of comment to tell me that you checked the negative 9 and it didn't work. All right, so that's the end of chapter 6, other than we just need to get through the practice test.